Hi, everyone. Good afternoon. Thank you for joining us today. This is our second block of sessions for Take 30. So today we'll be talking about building an AI strategy, and then I have for you here the agenda for the upcoming weeks. So next week we'll be talking about best practices, specifically feature stores. And then we'll be doing an ML intro for business leaders, just like a 101 of machine learning at the business leader level. So no math, I promise. From there, we'll talk about deployment. So we're actually bringing in Data Robot to talk about their ML Ops platform. After that, we're going to have a focus on higher education and use cases there. And then July 7th, we'll talk about AWS and building models in SageMaker and deployment into QuickSet. So that's our upcoming plan. To introduce myself, I'm Pam Askar. As always, I'm our data science director at Ironside. So I'd like to start with our mission, which is to help our clients use data to make better decisions about their business. That's what we're all here to do. And we do that really with over 20 years of experience in end-to-end data and analytics value. So we have capabilities on every wedge across this wheel, and data science really goes across all of them. Sometimes we sit or focus on one area. Today, we're talking a lot about strategy, which is kind of our advisory wedge, but we also provide the design, build, deployment management, and maintenance of all AI steps in the process. So Ironside's approach to building an AI strategy is right here, kind of simplified for you, and this serves as our agenda for today, starting at the bottom, just talking about how to build a foundational use case catalog to get started on, and collecting your tools, which includes both technology and people. Then starting to experiment with some rapid pilots, and finally scaling out once you've got that foundation under you. And I just have a reminder here, if you have questions at any point, you can write them in the chat box. Towards the end, we'll open it up so everyone can unmute themselves and ask questions verbally. But if you have a question in the middle, just enter it in the chat box, and Debbie will interrupt me and let me know, and we can answer that. So this graphic I've actually shown in maybe 2 or 3 other sessions. Actually, it's very popular. Really allows us to highlight a lot of important features about the challenges that organizations face when they want to grow in AI maturity. I've updated this actually for the 2020 results, but it's pretty similar to last year. Now, the reason I wanted to put this up here today is that when you're building an AI strategy, these are the challenges that you're going to have to think about and have a plan for how to overcome. And I specifically wanted to call out the top 2 of these. These are not issues that you need technical solutions for. These are strategic solutions. This is really where you need to start and put some time into. And that's why Ironside really emphasizes taking some time at the beginning to build this foundation, to collect use cases that are actually going to drive your business in the direction that it's looking to go. And we actually spent one of these sessions talking just about our approach to developing these use cases and developing that catalog, and how that process actually works to help your company drive culture, so that you can overcome that top issue. It's a little bit surprising sometimes when you think about it, that company culture is really the #1 concern or barrier to getting certain AI. And so as you start to identify use cases and get the business leaders involved and educate them, that's how you're going to help drive that culture. Now I'm going to put these yellow boxes up. The exact link doesn't matter. We'll send that out to you afterwards so that you can find the link to prior sessions and recordings of sessions that we've done, because today we're talking about strategy, and that's a lot of pieces of things that maybe we've dived into in more detail in prior sessions or will in future sessions. And so I just want to call those out because the use case session itself actually kind of went long. We had a lot to talk about. It's a little bit surprising how important that is and how much work you'd want to put into to set that solid foundation. And so if you want to know more about that and you weren't able to attend that session, we'll send out that link so you can listen in. A lot of what we talked about in that session really is this approach and making sure that you align your use cases with your key business objectives. So one thing that organizations often do when they're getting started is to say, okay, here's the data that we have, what problems can we solve? And when you do that, you might run the risk of spending time and effort on problems that don't actually need to be solved, or that you then have to sell back to the business and they're not ready, or you've misinterpreted something and it's not really aligned with what they need. And so you put yourself at a little bit of risk taking that bottom-up approach. We advocate for a top-down approach where you first identify your business objectives. What are the goals and problems that you're looking to solve for? What are the decisions and actions that are going to reach those goals? And then what information do you need to make those decisions and inform those actions? And then finally, you look at your data. Do we have the data to support that, right? And if not, we can look outside and find that data to support it. But what this top-down approach does is three things. One, it's going to help make sure that you're solving problems that your executives care about, right? That are aligned with the overall business goals of your company. It's going to help you to gain that business leader engagement and advocacy. That's really important. You don't want to be solving a problem in isolation from the people that are going to use that solution at the end, right? You want them engaged in it. And that's really one of the ways to drive cultural change. Get them involved in it, help them make decisions, help them educate you as a data science team, for example, on the data points, on how this data would be used, on what lens or scope to build that model. And finally, it's going to help you to avoid boxing yourself in and limiting yourself to just the data that you have, right? If you start with the data, like I said, you're not going to think about problems that you could solve if you pulled in external data. And on the point of external data, that was another session that we did just on the value of data enrichment. Data enrichment is what we call that process of bringing third-party data in to add it to what you have already, which can enhance your AI models. So if you want to know more just about that, I'd go there. The last thing I'll say about use cases is that what you're doing here is really trying to cast a broad net. You're not trying to find one use case. You're actually trying to find 10 or 20 or 40 use cases and catalog them and prioritize them and understand the value that each could bring, so that as you start to work through them, you're not putting all your eggs in one basket, right? If one is not working out, because AI models don't always work out, right? They're not all going to be big wins. If it's not, you can pivot away and start on the next one, and you can just churn through them and find value and then be ready to start on the next one once you've got one in deployment. So it really helps you build out that roadmap. So the next step on this, I said, was to gather your tools, right? You need people, and surprisingly, it's not one person. It's not a data scientist. Data science really is a team sport, and working in isolation tends to only get you so far. That deployment piece is really critical, and failing at deployment is caused by any number of things. Maybe it's a pilot that just wasn't really meant to go into deployment. Maybe it's the use case just wasn't viable. The data doesn't support it. But maybe it's also you misunderstood what the business needs, and so they're not going to adopt it and not going to use it. Maybe you don't have support from what I call data ops team, like data engineers and solution architects, to help you actually build the pipeline that you need to help build the solution to get it back to the end users. So looking at each of the people that I would say need to be involved in this team, I'd say an executive sponsor, right? That's going to drive that company culture. That's going to help educate the organization or support the education of AI to the organization, and offer funding, make sure that this is a funded project, that you can get the tools and the people that you need. That business leader, again, is critical. One, to make sure that you're solving the right problem for them, but also that they're providing their subject matter expertise. You don't want to misinterpret the data. You don't want to misinterpret what they actually need at the end. Data scientist, of course, is key. Like the data engineer, solution architect, that gets into the data ops piece, the deployment. And an experienced designer, which I always say is an undervalued piece of the puzzle here and piece of the team. Experienced designers can help us understand the types of questions that the end user asks and needs answered. They're going to help us understand how do they need to consume these final predictions. What form should it be put in, right? AI is a little bit nebulous. What am I actually getting, and making that tangible, making it something that is a metric in a dashboard that fits that end user's life and fits into what they need is key. So experience designers are a great piece of the team for that. Not technical people, right? Kind of that design thinking mentality. So the other piece is building your tech stack, right? So a few tips here. End-to-end solutions are fantastic, and that's a great way to go. But I also put the tip in here that you don't need to be afraid of multiple solutions. And I don't want that to be interpreted as saying go out and buy all the technology, right? Buy it all, because that's one approach. But don't be afraid to pull in best in breed or pull in something that can accelerate your process or works better for your team. Data scientists usually pull from a lot of different things. So not that you need to buy it all right away, but as you grow, think about ways to keep it contained, to keep it governed, but also to facilitate and accelerate, right? Take that path of least resistance. What's going to work best for your team? I also put turnkey solutions on there. That's not really part of a tech stack necessarily, but there are use cases that are solved over and over and over again. Like loan default is a good example. If you solve that for company A and company B and company C, you're quickly going to realize there are maybe 10 key drivers of that, and we know what they are. And so you can package that up and sell it so that you as a customer of that turnkey solution would just provide these 10 inputs in this format, and you get a prediction out of it. They tend to be black box, but sometimes it doesn't matter. You don't need that transparency. And my point with plugging in turnkey is, again, getting to that path of least resistance. So recreate the wheel if it's not necessary. NLP is one of those good examples. I could build that from scratch, but there's a lot of good solutions out there. AWS has legs, and there's several solutions out there, and so you can leverage those. And so when I talk about building a tech stack, it's bringing in things that can accelerate your work, like automated machine learning, and bringing in best-in-class things. Snowflake's a great cloud-based data warehouse that can facilitate a lot of the work that data scientists do, for example. My last tip about your tech stack is also to consider data science as a service to offload the stack, right? So if you're thinking about your AI strategy, and you're thinking about hiring this whole team of data scientists and buying all the technology pieces, and that doesn't seem like the right fit for you, data science as a service is a way to leverage somebody else's tech stack and people. So one of our sessions was actually on data science as a service and if it's right for your organization. So Ironside provides data science as a service called Ascend AI, and that would be a way for us to help you build out the use cases that are specific to your company, so not a turnkey solution. It's your data, your business problems, but leveraging our technology and people. The next step you want to do is executing some rapid pilots. When you're very new to AI, I would caution that you execute these pilots with the following goals in mind. First is to better understand how AI would work at your organization, right? So this isn't building the most important use case for your company, and it has high visibility and high cost benefit ratio at the end of it. It's about testing something out. So one organization I worked with, we built, our first model was customer satisfaction prediction. It wasn't the most important thing. It wasn't ranked highest on business value. We had like at least 30 use cases with them. But we did it because it's a metric that is clear and concise. It's one that that end users that we were working with understood. And so we built that so that they could actually start to see the process. How's this going to work at our organization with our data? And then they could see the predictions and get really clear examples of how does this fit into my work? Okay, now I see I'm doing my day job and now I have this prediction, and I can work with that and see it. I can see the drivers of it and start to hypothesize why these different drivers are impacting customer satisfaction, right? So we never deployed that model for a number of reasons, but when we started it, I don't think that was really intended, right? It was all about education. Let's get one under our belt. Let's get kind of a quick win, even though it's not, winning in the sense of being deployed and saving the company lots of money. So it's about education and getting your hands on it. Also, it's about identifying data quality issues, right? So you may get in there and realize that there's issues with data collection, with data governance, with just the trustworthiness of the data, there might be things that you can do, other projects that you can put into place to clean that up and fix it, so that 6 months, 12 months from now, you actually can go back to that use case and work on it. And that's a piece of data science that sometimes isn't understood, that, you know, you pick a use case, that doesn't mean you're going full force with it, because they're not all big wins, right? And so you need to be agile and flexible and say, okay, this isn't viable, let's move away from it. Maybe there's things we can do for it and take on the next one. Because finally, that last point there is to validate the viability of that specific use case. Is it good enough? Can it move forward? And so those are the goals you want to keep in mind. And rapid is kind of a key word. Pilots, especially at the beginning, it's not about investing everything. It's not about making it a huge project with final goals. It's about, let's test it. Let's spend the least amount of time possible to know whether this is viable or not, to get some learnings. And my tips there are, you know, don't be discouraged by failed pilots. Just be agile and move to the next one. And that gets back to having that catalog of use cases there, right? You're not picking one, you have a catalog to choose from. The other tip is to use this to educate and evangelize the organization on AI. And you know, use those learnings to redesign and reevaluate, to rethink your data or this process or the technology, or maybe you need different skill sets to bring in. So that's about just getting you started once you've got some tools and running through some pilots. And the last steps here are about scaling out, right? So eventually you've got some successful pilots, you need to deploy them, and you want more models, and you really want to scale up and out. So it's been estimated that only 22% of companies using machine learning have successfully deployed a model. We put on another session that it's also been estimated as much as 90% of models built never get deployed. So when I say deployment is a big hurdle, it is, and sometimes models shouldn't be deployed, and sometimes they could be, but it's a big hurdle to get over. So maybe you've heard of data ops, similar to DevOps, but different, and ML ops is sometimes, ML ops and data ops are sometimes used interchangeably, but ML ops is just a little more specific for machine learning. It's a set of practices that combines machine learning, DevOps, data engineering, that aims to deploy and maintain machine learning systems in production reliably and efficiently. So it's about building a process for continual design, training, testing, deployment, and maintenance. So ML ops is going to cover everything from, you know, building that pipeline and getting something into production, maintaining it afterwards, and watching for anomalies in performance or model drift. All models are going to get stale and start to drift in accuracy over time. Managing the retraining schedule, managing and governing who has access to the code, to updating it. All of that needs to be built out, and it's something that organizations that are still fairly immature aren't always thinking through the bulk of that work. And so this is really where that team sport comes in, having the data engineers, solution architects here. So I also wanted to point out that, I was going to say next week, but in a few weeks, we are going to have Data Robot come in and co-present with us on their ML ops platform that helps to make deployment and management easy in one single system. So we'll get to see that preview. The other part of ML ops that I wanted to call out is about building feature stores. Feature stores can be thought of as a data mart for all of the drivers, features, attributes, whatever you'd like to call them, that are created for models. Now, feature engineering can be as much as 70% of the work to build out one single model. So it's a lot of work. And what you'll find as you grow and scale up in AI is that you'll put all that work into one use case, and you'll put it all into another use case and another one, and then start to realize that you're using some of the same features, right? But you recreated them, and different people recreated them, so they use different code, different processes. So it's not very efficient. And putting them in a feature store where they can be tightly governed and reused and called upon for future use cases is a best practice in data science. Now, this seems like a no-brainer. It seems like, yeah, that makes perfect sense, but it's actually a fairly new concept. I think Uber actually coined the term feature stores, And some of the very mature AI organizations out there probably have been doing some form of this before it got really popular, known as feature stores. But it's something that most organizations have to figure out on their own as they reach AI maturity. And so there's it's getting to be that this is getting more common, and there's a little bit more information out there, but not a whole lot on how to build a good feature store. So this is something that I figured I would spend some time on. We have a session next week just on feature stores and about the importance of it. It turns out to be a little more challenging than you might think. There's a lot to keep in mind, a lot of governance and documentation. So this would really fall under that ML ops, and it's really there to help you scale up as you develop more models, as you deploy more models, reduce that rework, and also make sure that you've got some ground truth there and you don't have people coding things different ways. So my key takeaways for today, don't really look just for a problem to solve with the data that you have, going all the way back to use cases. Make sure that you're identifying your key business objectives and then aligning your use cases under them. And catalog as many use cases as you can find across the organization. We usually go out and interview all the different functional areas. Everybody has a ton of use cases. Any functional area in an organization probably has opportunity for AI use cases. And so you can catalog them, prioritize them, and set a roadmap for yourself. Data science is a team sport, right? Don't look to just hire one data scientist and have them work in isolation. That is where you're going to hit a wall with deployment, especially. And use technology that enables you and accelerates you, right? Look for something that works within your company, so you're not recreating the wheel, so you're not doing work that you don't have to, but that works for your team. And then execute low cost and low consequence pilots, right? Just test it out at the beginning, make sure that you understand how it's going to work for your organization, make sure your end users understand it and they get a chance to work with it a little bit. That again goes a long way in forming company culture in favor of AI. And then finally, to scale with ML ops. Be thinking about that, how you're going to govern it, how you're going to build that ML ops team, and feature stores specifically. So that's all that I have for today. Let's just open it up for some questions, and I'll sit back and be quiet for a second.
So thanks, Pam. We do have one question that's come in, Pam, and that's really as far as hiring. What skill sets should they look for when they're hiring data scientists?
It's a good question that I get a lot. And often, one of my answers is Python. Python is just dominant in data science, right? So you should know that. Obviously, you should know machine learning. But I don't really have a standard profile. You need these things, and you need to know these systems. And when I'm looking to hire for my own team, I actually rotate through it a little bit because I'm looking for the most diverse team. I have been the most successful and productive and happy when I'm working with a team of data scientists that have skill sets that I don't have, that can teach me things that I can teach them, and take some of the burden off me if it's not my expertise. So we work together very well. And back to that team sport, I would say there's just so many different technologies and so many different methodologies in AI that I think it would serve you well as you start to scale up and hire a team of data scientists to kind of rotate and look for different things. That being said, like I said, having some solid machine learning skills and knowing Python are key. The other thing I will say is if you really just can hire one data scientist, often I say go big and go with someone with a lot of experience who knows deployment and who knows business. They can hire someone a little less experienced and junior at some point who can do the machine learning and the coding. But if you just have that junior person, they often hit the wall with deployment. They probably haven't deployed a model, right? Only 22% of organizations using ML have. And so those younger people have to learn that a lot. So sometimes I'd say your first hire, you'd want someone who understands that, who understands how to get it back to the business and who understands how to extract use cases from the business. It was kind of a long answer, but.
Well, thanks, Pam. We have another question too. Can you talk a little bit about software, open versus actually buying software for data science?
Like open source?
That's how I interpreted the question, yeah.
Yeah, there's a lot of open source out there, and there's a lot that you can do just with Python. Cloud computing is very valuable because it's a low cost way to scale up, and you can call those open source resources. So that's fine. The where you step into buying actual software, and I would still have my preference be something cloud-based, is to accelerate things. We'll talk to DataRobot in a few weeks. Their auto machine learning, and we talked, I think it was just last week, with IBM's Auto AI platform. Those are really great ways to accelerate and get you through your use cases faster. They're often marketed to teams that have younger staff or that might not know Python, right? But understand the concept of machine learning, and you can level people up. So I think that's great, but they're also very valuable to myself or my team because they just speed things up, and they also have the deployment MLOps package that makes things easier. So again, you don't have to struggle with writing everything from scratch and looking for open source if all of those are kind of neatly packaged up somewhere, and you can do that. But it doesn't mean that starting with open source is a bad spot at all.
One more question. You had mentioned feature stores, and that would be coming up in a future session. But could you talk a bit more about what a feature store looks like?
Yeah. So let me go back a little bit. So I have an example here where you might have a customer table, and you might have a customer product table and policy table and claims. As you think about a model that you might build, if it's insurance underwriting, you're trying to predict the likelihood of a claim happening, these are some topics that you would be pulling features on. You might have customer demographics like age. You might have their policy and all the details of their policy, a claim that happened, the date it happened, what happened, and all those details. And then later I come in with another use case where I also want customer demographics, and I also need to know their policy information. So rather than recreate those, I want to have them here. Now, as you're building this, you want to do some of the feature engineering, and the trick is not all of it, because as you're building one use case, you may be saying, oh, I need 2 years of historical data for this, or I'm scoping it this way, and so it limits it. The other use case might be scoped a slightly different way, and so that's why there's some careful consideration as you build this and how far you want to take these features. And you know, you may want customer age, but 2 years from now you're doing another use case. So you don't put in age here, right? You put in you pull in year of birth, so it's here and it's available, and you can calculate age later. And so it's really going to be dependent on the organization, and it's another thing that's going to scale out. But very careful documentation of how you got to all of these, and careful governance of them is going to be important.
If we have another question, I'm just not sure of the timing, if we may have already answered this with DataRobot, but I'll let you say a little bit more. It says, are there specific tools for continuous development and integration that cater to MLOps?
Yes. So read that again. Are there specific tools?
Yes.
That
are there specific tools for continuous development and integration?
Yes, so MLOps, which is the name of DataRobot's platform, specifically handles that very well. And I think the continuous development part might be the auto retraining, right? Because you build a model, but you also want to retrain it every so often on some schedule, and that is going to be very dependent on the use case. And so, yes, you can have an MLOps platform that's going to handle that kind of auto relearning, autonomous learning, it's called. So that can be part of it. I'm not sure if that's exactly a feature in DataRobot's platform, but that's part of MLOps, and what you want to keep in mind is that schedule of relearning.
Terrific. That is all the questions we have for today, which is good because we're at our Take 30 time.
Great. Well, thank you so much, and I look forward to talking again with you next week.
Terrific. Have a good week.